Imran. Okay, so from SUSE, Mr. Lim, he will do a presentation, and Mr. Chammpika from Rakuten, he will do a presentation. So this will be our agenda today. So we have only two topics. So we reduce it to two because we want to give more time for our speakers. So and they will have a good content to deliver to you, right? So we always welcome sponsors and speakers. So you can contact us, or you can contact through these links if you're willing to be a speaker for our next events, or else if you want to sponsor, yeah, we always welcome you guys. Yeah, so I'll be handing over the mic to Mr. Imran. Yeah, thank you.
Testing 1, 2, 3. Okay, everyone can hear me, right? Okay, a very warm welcome to Rakuten Asia. Today, I'll give you a short introduction to Rakuten. My name is Imran. I'm from the talent acquisition team here at Rakuten Asia. So Rakuten is the company based in Japan, and Rakuten Asia is part of the global expansion of Rakuten and is the regional headquarters of Asia located here in Singapore. Our office houses all of the Rakuten's business verticals such as Rakuten Wiki and Rakuten Travel, to name a few. So here's an overview of the 11 different businesses based in Singapore. So moving on to our philosophy, we want to contribute to society by creating value through innovation and entrepreneurship. So through providing such high quality services, we aim to shape the future through three different initiatives, mainly innovative technology, empowering employees, as well as maintaining numerous green initiatives. So we also have partnerships with global brands such as the Golden State Warriors based in the US, the sports team Vissel Kobe, as well as Rakuten Eagles in Japan, and as well as famous speaker Mary Kondo. So moving on to our culture, as part of Rakuten, we believe in the value of entrepreneurship, lofty ambition, as well as a sense of unity. Here are some recent events that was organized. So we regularly organize TED Talks, seminars, as well as workshops. So one of the recent events that we organized here was the recent hackathon called Hack Social last June. We also have workshops that are regularly organized, as well as other socials and tech talks. We also organize social events for employees, such as festive celebrations, as well as sports day and sports competitions. So before I end the presentation, feel free to find us on our various social platforms such as Instagram, Facebook, and LinkedIn. And of course, if you like to tag us, you can use the hashtag Rakuten Tech Talks. You can also scan the QR code here on screen for current job opportunities here at Rakuten Asia. I'll now pass the time to the next speaker. Share the screen.
Okay. Sorry? Just go to the visual presentation. Yeah, okay, maybe. Just switch. Let's see.
This one.
Okay,
Yeah.
good. Hello. Hi everyone. Very warm welcome to this committee meeting. So I think the reason why we are here is because all of us have a common interest. So we are all into Kubernetes. We want to find out more about Kubernetes, which is why we gather after office hour, right? So we are. No, I'm from SUSE. You can see from that over here. But I don't want to make this event talking about our company, how long we have been around, and things like this. We just want to talk about the technology and then share the experience that I have. I know many of you are experts and could be even better than me. So what I can share is my experience with SUSE on Kubernetes, on Ranger, which is the management platform for Kubernetes, as well as container security. So without further ado, let me start with my presentation. So there's two sections for my presentation. I'll start with some slides to talk about the Ranger ecosystem before I follow on with my demo. So the demo will be on Ranger and on New Vector. Okay. So to give everybody a better context on our Ranger ecosystem, right? So yeah, this is the high-level architecture of Ranger. Okay, you can see my mouse, right? Okay, good. So yeah, typically for Ranger, I think it could be a little bit different from some of the other, Kubernetes distribution. So for us, we have our flagship product called Ranger Prime. So Ranger Prime is the management GUI to manage multiple Kubernetes clusters. We can in fact manage up to a few thousand clusters from the management GUI. So we also do not have to buy customers down to a particular stack of Kubernetes distribution. So we have our own distribution, but we allow customers to choose whatever they want to. And we want customers to have the best experience when it comes to managing Kubernetes. You can be using our distribution, or you can be using AKS, EKS, and the experience is going to be the same. You will have full lifecycle management capability. So as you can see from here, from one server, I've just put two downstream clusters over here, right? But one, you can use our RKE on-prem or even in the cloud on top of EC2, for example, or you can run AKS, for example, the hosted Kubernetes EKS. It's up to you to use your Ranger to manage any Kubernetes distribution or clusters. So this is the Ranger ecosystem. When we talk about Ranger, a lot of people don't really understand, what Ranger represents. So you can see from here, there are many products that exist within the Ranger ecosystem. It is broadly separated into a few categories, so platform, distribution, and on. From the platform perspective, this is the management GUI. We have recently rebranded it to be called Ranger Prime. So nothing else has changed. If you have used Ranger before, so probably a show of hand, how many of you has used Ranger before, experience with Ranger? Wow. Okay. So I think I might need to do more, selling of our products in this case, right? Yeah. Okay. Then, yeah. But typically, maybe after this session, I think you'll have a better understanding on what Ranger is. But do bear with me for a while first. Let me go through this slide over here to showcase the Ranger ecosystem. So Ranger Prime, central GUI to manage multiple Kubernetes clusters. It's a platform for you to manage Kubernetes. Together with Ranger Prime, there is something called Flip. So Flip is built into Ranger Prime. You do not need to use another platform. It's built into Ranger Prime already. So Flip is meant for if you are a developer, you have your own Git, you put your codes in the Git, and you want to deploy after you do some changes to your codes. So Flip is going to enable everything to be seamless. You make any changes, we can, as long as we sync up to Ranger Prime and Flip, So once you make any changes, you can automate the whole process so that any code that you change can be deployed directly into any clusters that you want to, as long as it's managed from the virtual server. So this is great. And now we have Kubernetes distribution. So any one of you use vanilla Kubernetes, or may I know what are the distribution that you're using? Other than Rancher, anything else? Oh, the hosted Kubernetes, EKS, okay. Okay. So nobody using vanilla Kubernetes. Wow, good. So I think for those people who are adventurous enough to try out vanilla Kubernetes, they will find that it is experience of deploying and then doing upgrades, right? It's not going to be an ideal experience. So especially for Kubernetes, we know that every 8 months there will be a new version around there, right? So every time you need to do the upgrade, it's going to be a pain. And Kubernetes upstream does not come with many important components that make your cluster ready after you deploy it. For example, doesn't come with any CNI. So you deploy a vanilla Kubernetes cluster. After that, how are you going to consume the application? There's no way for your application to talk to one another. So you need to have a distribution to ensure everything can be done in a much more easier manner. Over here, we have RKE, we have K3S. So these are the distribution whereby it's just putting all the components together into the form of installer. And then after you deploy it, it gives you additional features, mostly from a lifecycle management aspect of it, things like doing backup of the cluster and doing upgrades. So it's going to make things so much easier for you to consume Kubernetes. We have two variants over here, RKE and K3S. RKE, now we call it RKE2. RKE2 used to be called RKE government. So you see the word government, the key aspect of it is security. So we work closely with DoD to come up with RKE2 to ensure that it is security enhanced Kubernetes. So RKE is meant for data center. Typically, data center, you don't have any problem when it comes to resources. No problem with network connectivity. So it's a full-fledged Kubernetes distribution. You can choose. It comes with many different kind of add-ons for you to choose. So if you are deploying Kubernetes in the data center, then RKE will be the good choice for you. For K3S, it is developed, with edge in mind, deploying Kubernetes on the edge. So it is a CNCF certified lightweight Kubernetes distribution. So the key thing is, despite the fact that we make it very lightweight, we make it into a single binary whereby you can just, I think it's around, I can't remember, 18 megabyte or something. So you just need to put the installer, the binary, into a USB stick. You can just go to anywhere, install it, and then after that, you have a Kubernetes cluster up and running already. It's as simple as that. So despite the fact that we took down so much of the coding around Kubernetes and come up with K3S, right? It is still CNCF certified. So everything is very easy for you. I mean, over here, what we aspire to do is to make everybody consume Kubernetes in a very easy manner. So this is what we aspire to do. And especially for the edge, it's always difficult for you to do anything on the edge. So K3S is definitely something that's very good for you if you intend to deploy Kubernetes on the edge. Okay, so now I'm going to talk about the add-on. So add-on are something that you can use on top of the platform or the clusters. So typically, we have something called NewVector. So NewVector is a product that we acquire, I think, early last year or late 2021. It comes with full lifecycle container security. A lot of the customer or users of Kubernetes, when they first deploy Kubernetes, I think their whole, the whole motivation of them is just to ensure that they deploy a cluster that is good enough for whatever usage they have, be it production or whatever. So security is always something that is an afterthought. After they deploy, they run it for a while, especially for enterprises, run it for 1 or 2 years. They thought that the traditional security tooling is good enough for Kubernetes. But after 1 or 2 years, then they discover, hey, there's a lot of gaps here and there, we need to fix it. And this is where it starts to get more difficult because you already deploy your application and then you need to fix all the problems that exist after that. So probably a better way is to ensure that when you first deploy the whole your whole cluster. You ensure that security is not something that's of an afterthought. You ensure that security is taken care of right from the start. So we feel that New Matter is a solution that is very useful in helping everybody achieve the kind of goals. So I'm going to demo on New Matter later on, and I have a few more slides on New Matter, so we'll talk more about that. So Longhorn is for persistent block storage. It's also an add-on to the Rancher platform, right? So typically when you are using Kubernetes, you intend to use it as a stateless application. Stateless, every time you rerun the container, is guaranteed to be the same. But if you are running things like a database, how are you able to do that? You need to have stateful set, you need to have volumes that's being attached to it automatically, making use of the CSI driver, as well as the backend whereby there will be redundancy. The storage is able to do duplication or rather replication across multiple nodes. So Longhorn is something that allows you to do that. Once you deploy Longhorn on the clusters that on the Kubernetes cluster that you're running, you can get all these features right out of the box after you deploy Longhorn. So it's going to make things very easy. It's going to make use of the local storage. So just something that you can think of if you are intending to run stateful application. Harvester is hyper-converged infrastructure that's built around Kubernetes. So you can deploy Harvester on top of bare metal machine, and then you can consume hyper-converged infrastructure, which is virtual machine from there. The beauty of this is after you do that, it is cloud native, it is Kubernetes aware. You are able to run both virtual machine and container from a single pane of glass. So this is the value of Harvester. Sorry? No, Longhorn is not SAFe. Longhorn is another solution, another technology altogether. So SAFe is something, so SAFe used to have SAFe many years ago. Recent 2 or 3 years ago, we EOL SAFe. SAFe is a very good product, but it is very heavy. You need to have many nodes in order to just deploy SAFe. Whereas for Longhorn, it is more of a kind of distributed storage that make use of the underlying local storage. So it's easier to consume. You don't need to have another cluster solely for storage. You can make use of the cluster. You can make use of the storage that reside within the Kubernetes node itself. So may I know who is the one who asked the question? So anybody who asks question can get a gift. We have different kinds of gift over here.
Oh, they change the color.
Rancher color. So Rancher is blue color. SUSE is green color. So I think he must have attended our expert days before. So this is the Rancher layering. We put everything into something like this, right? So that it's easier for everybody to see which layer our products play in. So we have been around. We are a Linux company first and foremost. We've been around since 1992. We are the first company that come out with enterprise Linux. Sorry, I'm going to tell a bit about SUSE. So at the bottom there you see this is our OS. But when it comes to the whole Kubernetes layer, this is just one of the many OS that we support. We also support RHEL. We also support Ubuntu, Oracle, and other Linux. So normally when you deploy Kubernetes, you need to have the node. You need to deploy the node. You need to install operating system in the node. So since we support within our Rancher ecosystem, we support all these operating systems. So feel free to continue to use whichever operating system that you are familiar with, you are proficient with. And then after you deploy the node, you can deploy the next layer, which is Kubernetes. So as we discussed earlier on, we have K3S that is meant for the edge, we have RKE that's meant for the data center, and then in the cloud, you can deploy RKE or K3S in the cloud as well on top of the instances, or you can make use of the hosted Kubernetes. Hosted Kubernetes can be Amazon EKS, Azure EKS, Google GKE. So as long as it is CNCF certified, Rancher Fly as a management GUI is able to manage all of them. We support up to 2,000 clusters minimally. So and I think if you are familiar with Kubernetes, right? Kubernetes is designed solely for container orchestration and management. So come with many infrastructure tooling around it to make it a complete platform. With Rancher Prime, it comes with a lot of added features. You can see from here categorized into different category as well. Simplified cluster operation, policy enforcement, governance, authentication. We are able to be connected to all these various authentication provider within your organization. So you don't need to reinvent the wheel. All you need to do is to plug branch it into the organization, make use of any authentication provider that you have, and everything is good to go. So platform services, out of the box, we provide many critical components that is able to make your Kubernetes cluster ready for production. So this slide shows what are the components that come out of the box, right? You can see on the left side, you have the Rancher Prime SLA. So these are the components that you are able to consume out of the box. You deploy a cluster, you can consume any of the components over here. So critical components like Grafana, Prometheus, Fluently for logging, and HTO service mesh. If you are running your own application, I think likely you might need to run API gateway or HTO as a service mesh. So all this you are able to consume out of the box without any additional cost as long as you have a valid Rancher subscription. Of course, you can see there are a few items over here that comes with S3. So this requires additional subscription other than the Rancher Prime subscription. Probably let me sidestep a bit. First and foremost, we are an open source company. We don't sell licenses, we sell subscription. So whenever you deploy our product and you need to have support for it, you need to get a subscription. You can get a subscription from us, and whenever you run into any issue, feel free to reach out to us, our support team. We will fix your issue on your behalf. So as good as buying guarantee to ensure that anything goes wrong, you are not the one being responsible for it. So other than Rancher Prime SLA, we have something called Rancher Prime Ready Partners. Typically, the Kubernetes ecosystem is growing day on day. There are so many projects out there. There's no way for a single vendor to support every single component out there. So every component has their merit, and everybody has their own preferences, have their own. They might be familiar with a certain components compared to the other component. So what we do is we don't want to buy customer down to the stack. We allow customer to choose whatever that they want to, and we provide integration support for it. So rest assured, any of the components is listed here, when you deploy into the Rancher ecosystem, they are guaranteed to work. If not, please give our support team a call and they will try to fix it for you. And this is not the full list. These are just some of the components that we picked up, but there are many more components that we support as a Rancher Prime Ready Partners. Okay, now I am moving ahead to new vector. Any question? So you can get some gift other than okay. So anyone wants some plushie? Please. Just ask a question.
What is new vector?
Okay, great question, good question. I'm going to touch on that. So I think the other gentleman deserves a plushie also. He already knows a lot about new vector. Okay, so new vector. New vector is as we put over here, right? Only 100% open source, zero trust container security platform. Only. Typically, when we talk about container security, people talk about supply chain security. But what new vector offer is something called runtime security on top of supply chain security. Supply chain security is probably a very good starting point. But then after you deploy your cluster, you might find that supply chain security itself might not be good enough. So supply chain security, you are doing things like vulnerability scanning of the images, copyright scanning, runtime scanning of the instances or the containers that's running within the cluster itself. So, it seems to be good enough, but there are some gaps, and I'm going to show you why are there some gaps. Whereas runtime security, it comes with, the key thing is zero trust. So you only allow things that you trust to be running within your Kubernetes cluster, and you use whitelisting rather than blacklist. Whitelist to ensure that only those that you are 100% sure that it's not going to cause you any problem, those are the ones that they are being allowed within the cluster itself. So bear in mind all these things. I'm going to talk about it later on in the upcoming slide. Supply chain security, just further some context on supply chain security. Typically, when the developer code is going to put into CI/CD pipeline, going to put into registry before pushing the code to be run as a container. So at any stage, you need to have a proper, container security, container scanning tool within the whole pipeline, right? Within the whole supply chain, right? So New Vector is able to do that from CI/CD pipeline to registry to when you're already running in Kubernetes itself. So as you can see from here, provide full life cycle scanning from the time when image is built until the image has been deployed. Scanning is performed on every single the whole cluster as well as the underlying nodes and the platform. Okay, contextual runtime. Contextual runtime is something different, something that we pride ourselves in to be able to come up with something like this, whereby I don't think any of the competitors out there are able to have something similar to us. So it provides real-time inline visibility of packet flow, application protocol, processes, and file system access, both in the east-west and north-south traffic. So typically, when what we are able to do is when someone starts a new process, so you can see this guy over here, I don't think he's a nice guy, right? So he's going to make something funny to your cluster. So when he tries to do something that is not being allowed in your cluster, New Vector is able to detect based on the contextual runtime rule set. And then it is going to terminate the attack or it has a chance to hit the target. So it gives you time to find how to fix, this security risk. So runtime security, let me go back a few slides. So it consists of contextual runtime, which is what we pride ourselves in, and things like it's able to do threat-based control based on signature and zero trust control as well. There's a bit of an overlap between, let me go back, runtime security and runtime scanning. So, runtime scanning, typically when you're talking about CVEs, you're talking about emission control, that is normally runtime scanning. But it is also threat-based kind of threats. So, we group them together. So things like CVEs, DLP, network attacks in both layer 3 and layer 7 offer top 10 best practices for web application emission control. So all these are things that are already well defined. It's already identified. So we know what the threat is, we know the signature of the threat, we are able to solve we are able to block any of this threat coming into your cluster itself. But these are things that are easier to block as compared to those things that you might not know. So zero trust is precisely meant to do the later of it, which is to block things that you yourself might not know in the first place. There's no signature attached to it, and since there's no signature, you are not able to use your threat-based control to block the threat from going to your cluster. For example, CVEs. A lot of CVEs out there, even though they are defined, but many CVEs after 1 or 2 years, there's still no fix for it. So there's no way for you to close the gap from a vulnerability standpoint. Another example that I want to cite, zero-day attack. Zero-day attack is attack that it just came out. There is no signature at all. Nobody even know what it is. So you need to have a better way to prevent all this threat from going into your cluster. What we do is we are able to do automated learning. We are able to monitor the network behavior based on both layer 3 and layer 7 of the OSI model. We are able to know what are the process, what are the file access and behavior that's residing within the cluster, within the container itself. So that anything abnormal happen, New Vector is able to detect it. And last but not least, security as a code. Whatever rules that you set in one cluster, it's very easy for you to just take it out and put into another cluster. Okay, one last slide. So just want to showcase an example on automated behavior based zero trust, how we implement the whole thing. So typically, we want to use network as the single source of truth. And you can see from here, this is a typical Kubernetes cluster. And in a Kubernetes cluster, the key thing that's different as compared to the traditional way whereby you deploy an application is there is way more east-west traffic as compared to the old way of deploying application. So the old way of doing tiering, network segmentation, firewalls on all the network tier might not be good enough in this case. You need to have a better way to manage it. Something like micro segmentation, whereby you are able to allow rules to be set for every single container, and those rules that you set will be each itself going to be a segmentation. So it's going to be something that is way more advanced as compared to the traditional security tool that you typically use for traditional infrastructure. So traditional infrastructure security tools might not be good enough for container infrastructure. So east-west traffic, and other than east-west traffic, there's also north-south traffic that you need to deal with. So both east-west traffic and north-south traffic, Mgmt is able to make use of our patented bit packet inspection to detect the layer 3, layer 4, layer 3 and layer 4, layer 7 protocol, as well as the processes to understand what is actually happening within the cluster itself. So we have something called discovery, monitor, protect, different mode for you to put your cluster into later on during the demo and to showcase that. Okay, so just a summary on Mgmt, right? Security from development to production, every single stage of your Kubernetes journey, right? From the container lifecycle to layer 7 application micro-segmentation, threat protection, zero trust protection, and something that I haven't touched on is compliance reporting. So this is something that is very important as well. Yeah.
Mgmt deployed as a sidecar.
Very good question. So Mgmt is deployed as a container. We have different kind of containers for Mgmt. So there's a controller container, there's a scanner container, there's a but what is the last thing called? Controller. Okay, just slip my mind. But basically it's deployed as a container and not as a sidecar. The reason why we don't want it to be deployed as a sidecar or deployed as an agent is because of performance issue. So the way we do it is able to scale better performance as well. No, it's residing within the container itself, so you don't need to modify anything. All you need to do is to deploy Mgmt within the cluster that you want to monitor, and you're good to go. Okay, so I'm talking about compliance, right? Compliance is very important, and especially for Kubernetes, you need to have a better way to see through all your assets, right? There are so many assets within Kubernetes, all the way from your application to the images to the underlying nodes. You need to have a good way to be able to see from a compliance point of view any of these assets. Is there any lapse in compliance? So Mgmt is able to do that well. Okay. I'm going to demo now. I think I'm running a bit short of time. So any question? Please. Very good question. So when the breach is being detected, after it's being detected, right? Typically it buys time for you to find a fix to the solution. So one way is to do virtual patching. And virtual patching, I think, is something that Mgmt can do well because we are able to block the container in such a manner whereby we provide whitelisting. Only those traffic, those connectivity that you are sure it is not an attack, not something that is malicious, is being allowed within the container itself. So by doing that, you are able to continue to get your application running without without being worried that it might become something malicious. Yes, you can do that. That's one of the things that you can do with Mgmt. Are there any kernel modules in the worker node? May I know? Can you please further elaborate on the question? Kernel modules from the OS layer or from Mgmt? Mgmt, no. Mgmt is being deployed as a container. Yeah. Please. Sorry, I don't really get your question. I think it's a yeah.
System is exposed by an application by accident.
File system.
Yeah.
Okay.
Like the web server. By mistake, it's like misconfigured to expose file system. Maybe it has master files on it.
So new method is able to detect and yes, it's able to detect any anomaly. We have web feature built in. So if you want to use web with new vector, you are able to do that as well. Yeah. So, sorry, do we have another mic? Ah, good question. So during the demo, I think you will get a clear picture. So what we do is to get the baseline. After you have the baseline, right? Anything that happens outside of the baseline is considered to be an anomaly. So you put it into probably the demo is going to showcase that in the clear detail later on. Sorry? False positive, good question. So this depends on how your cluster is talking to applications or talking to users and things like this, right? Typically, there are for some customer, in fact, they don't want to put new vector into a mode called protect mode. So protect mode is very restrictive. Anything that happens outside of the baseline is going to flag, it's going to block. The other way is for you to put the cluster into something called monitor mode. So during monitor mode, the traffic won't be blocked, but you will be notified of any anomaly that happens. So there's no way, there's really no way when you are putting your cluster out there, there's so many traffic all over the place, especially it's a application that is already being accessed by thousands of people. There definitely there will be some false positive. So it's a matter of how you're going to manage the false positive. Sorry. Please. So I didn't really catch your question.
What is for identity? Identify the workflow time. We use like IP address to identify the different workloads, or do you use labels, do you use something like sticky? How do you identify? How do you use identity?
You mean when application talk to another application? Application talk to another application. So IP address. Okay, let me think about it. Okay, I get back to a question in the short while. So it's a bit of a mental block now. Yeah. Your question?
Will there be any impact in performance because you're doing two packet inspection per layer and layer 7?
Yep. Sorry.
Will there be any performance impact because
Okay. So from a performance impact standpoint, right? It depends on is that into monitor mode. So monitor mode is more of just monitoring traffic by putting the tracking device to be in line with the traffic. Whereas if you put into protect mode, then the performance is going to take a bigger hit because there will be more activities that's happening. I don't think there's a hard and fast figure that I'm able to share. It depends on each and every individual workload and things like this. Okay, so we shall proceed on to the demo now. Yeah. My hand is getting tired. Okay, thanks. Okay, good. So this is Venture web GUI. When you log in, you will see this. So just now I asked who has used Venture before. So I don't think so. Most of you haven't used Venture before. So I think this could be something that's not really familiar with you. But after you log into Venture being the central management GUI, you will be able to see all the clusters that are being managed from the Venture server or Venture client, as we just rename it. So you can see from here at this point of time, there are two clusters that are being managed by Venture Prime. Local cluster is where Venture Prime itself is residing on top of. So you can see from here, we have one cluster called AWS RKE2 NB. We deploy RKE2 on top of EC2 in AWS. And we have another cluster. So this is my local cluster residing within my own my house. So I didn't turn it on, which is why you see it is unavailable at this point of time. So If you go to the top left corner over here, you click on it. This is the home menu. You can go into any cluster and explore from there, or you can access to some of the applications, some of the global app like continuous delivery, that's for fleet, virtualization management, harvester. I'm not going to touch on all this. It's going to take too much time. So what you can do now is probably can check out cluster management. After you go into cluster management, you are able to do some lifecycle tasks on the clusters that are being managed from Azure Prime. So for example, you can click on AWS RKE tool over here, and you can see the underlying machine provisioning log, how it was provisioned, and some of the recent events from a cluster perspective and things like this. So right now, these are for the for the infra side of things on the cluster. If you want to go into Kubernetes side of things, you want to see what are the objects that are currently running within the cluster. So what you can do is probably you can go back to cluster management over here, and then click on explore. Right. After you click on explore, you are able to see from the context of Kubernetes all the objects that's residing within the cluster and things like this. So one thing before I move on, let me go back to home. I just want to show you how easy it is to create Kubernetes cluster by making use of Azure Prime. So all you need to do is to click on create. There are many ways that we can provision a Kubernetes cluster. So you can make use of nodes that you already provisioned and then run RKE2 or run K3S on top of it. Or you can provision new nodes, everything automated. So you don't need to install, you don't need to deploy the nodes, you don't need to install OS on the node, you don't need to install Kubernetes on top of it. Everything is automated. If you have the right credential and the right connector set up to any of the providers over here, can be EC2, can be VMware vSphere. And finally, you can run the cluster on the hosted Kubernetes. So what I'm going to do right now is I'm going to run a cluster running EC2. So I have my credentials set up already. So just give it a name like AWS RKE2. And the region I got to set it to one that I have set up, US East 1. And then you can put in the instance type, you can put in the machine count, it's up to you, the row as well. Let's give it the right VPC subnet. And over here, you can choose the Kubernetes version. So I'm going to choose a lower version. If we have the time later on, we can show you how easy it is to upgrade from a lower version to a newer version. And then we click on create. And in probably 5 to 10 minutes, the cluster will be up and running. As simple as that. So, okay, wow. So, out of the box, right, there are many applications, as I showed you earlier on, that you can consume on the cluster itself. So, okay, let me go to the cluster now. I click on this, I go into the cluster. I'm exploring this cluster, AWS RKE2NE. I click on it. I go into the cluster. And you can see all the objects, all the workloads, service discovery, everything within the cluster from a Kubernetes standpoint. So I have deployed some of the tools that come out of the box for you to consume. So monitoring tools, whereby it is making use of Grafana and Prometheus, I have already installed that on this cluster itself. So you're able to see graph that Prometheus and Grafana provide you with. Or alternatively, you can go to monitoring over here, click on this, and then you can go to Grafana if you want to check out all the graphs, all the matrices have been predefined for you. Or everything very nicely done up. So right now, I have also deployed new vector on this cluster. So we can click on new vector, and then you can access new vector from here. So I click on new vector, and finally we get to see new vector. We have been talking about new vector for quite a while, and this is the web GUI for new vector. After you log into new vector, you can see on the left side, these are all the assets that these are all the options that you have. Okay. So firstly, the dashboard. So when you go into new vector, you are able to see all the critical security details of your cluster, ingress, egress exposure, the security events, what are the ports that are vulnerable, and things like this. And some of the options I'm going to show you later on. The next thing I'm going to show you is the asset. So everything from a Kubernetes standpoint, right? From the platform to namespace to nodes to containers and registry. New Vector is able to check out every single aspect, every single component within your cluster itself, and see that whether there's any security risk or vulnerability left. So registry, you are able to add third-party registry for you to for New Vector to add to New Vector and then check whether is there any depths on any of the registry, any of the images residing within the registry. So for example, I have add a couple of example. It's my I'm not able to scroll, I don't know why. Okay, never mind. So you can see from here, I'm able to I have add a couple of registry over here. Yeah, a couple of registry over here. And it can be just a single image that we are checking on. Or it can be the whole directory. It's up to you. Need to make it smaller, I think. Okay. So I think the view is better now. So I can scan all the images residing within the registry to see whether is there any of the images, is there any less. So for example, over here you can see that for this particular images, there are many vulnerability. Okay. So right now, the next thing I'm going to show you. Okay, let me go through some things here first. So policy is the place whereby you go in there and then you set the policy that you want to, be it network rules or file access rules. And this is the next item is security risk. So over here as security risk, you're able to check out what are the vulnerabilities within the whole cluster itself, which CVE has the highest hit rate and things like this. You can also check out compliance. So click on compliance, you can see what are the compliance issues that the cluster has from a Docker standpoint or from Kubernetes standpoint. So many things that you are able to see from here. And then when we talk about compliance, right? Typically, we are talking about CIS, we are talking about PCI, GDPR. So everything is categorized. In the event that you want to run a particular compliance report, you are able to do that based on whichever regulation that you are interested in. Please. Zoom in, okay. Yeah. Yep. So basically, there's a typically for regulation, there are certain guidelines that the regulator come up with. So for Kubernetes, for Docker, there are specific guidelines. So we need to ensure that the particular platform is adhering to the regulation based on guidelines that was given. There's some, the US government will come out with all these guidelines to ensure that Kubernetes is working with the all these authorities. If you talk about those nitty-gritty details, I'm not able to advise on that. From an infrastructure standpoint, there are certain regulations, certain rules that you are able to set and to ensure that the particular infrastructure is compliant with. Very good question. So New Vector, there's a scanner aspect of it. A scanner that's being deployed as a form of container. So the scanner is going to contain the latest CVE version. So every day, typically whenever there's new CVE that's being defined, the scanner is going to go through it's going to spin now, and the new scanner is going to spin up with the latest version of CVE. Yes. You have set whatever you want to. So every time you deploy a new pod, will be scanned automatically, or you can set, whichever frequency that you want to. Yes. So new vector is very easy to deploy. It's just running containers, right? Deploying containers, right? So I don't think there's a need for Terraform, which is more for infrastructure. So for us, we are making use of YAML file security as a code, whereby you are able to put all the security policies into a YAML file and then use the YAML file to move it to another cluster if you want to. For deploying of new vector, yes. Yes. We are using object. So, sorry, please.
The compliance filter is, whatever the options we see, there is something including all is having, some other rules out of the other filter. For example, consider the top two. Top two is another, the certification that we have. It's not certification, but maybe the type of collaborative. It is not information. So, when you select all, it is something that is selecting all, I don't want to understand. When you are selecting all, it is not only about those selected other filters.
It comes with some other filters as well. So probably I can just scroll down to let you take a look. So these are the full lists. So if I some of the list,
So it means, here the option is not.
I am not able to advise on that. I don't know whether it includes every single rules that's been defined in SOC 2. But I think we have a pretty comprehensive rules whereby you are able to set.
Okay, thank you.
Okay, so right now I'm going to show you how the whole thing works. Okay. Yeah. Sorry, give me a moment. Okay, so right now I am going into going back to hang on a moment. I'm going to policy and I'm going to emission control. So emission control is to prevent unauthorized images from being deployed into the cluster itself. I have set a rule over here. So it is to deny any images from being deployed onto the default namespace. You can click on this and then you're able to, there are many things that you can set over here. I'm just, setting a simple one whereby it's to deny any images from being deployed onto the default namespace. So what I'm going to do now, okay, before that, you can see that over here, there is the status. I need to enable emission controller. Let me enable it. And then you have two modes over here, protect and monitor. I'll put to protect first, and then we see what's going to happen when, when a pod is being deployed onto the default namespace. So I open another window over here. You can check out the notification. I can just put it there so that it's easier for all to see. Under risk report, it's going to be a risk because you are going to deploy a container that you're not supposed to be deployed onto the namespace. So what I'm going to do now is I'm going back to Rancher File and I'm going to show you how easy it is to deploy some application. So firstly, I am going to apps. There are many charts that come, many repo that there are a couple of repo that come off the box whereby you are able to deploy Rancher core components and some of the partner chart. But I've added a couple of repo, right? So over here, I'm able to probably deploy a WordPress application. So again, it's going to be very simple and straightforward. I'm going to chart. I'm just going to the Rodeo repo. So you can see that I have Bitnami added as well. So I click on WordPress and then I'm going to install and deploy WordPress into the namespace called WordPress. Something as simple as that. I'm going to give it a name WordPress. Click on next. I'm going to give it a password. And I'm going to give it a load balancing so that you are able to access it from anywhere in the world by making use of sslip.io. Okay, one moment. I need to pull out the IP address. Sorry. So this is the IP address that I'm going to pull out. Okay, so I'm going to install. Everything is going to work in a few minutes time. But before that, I'm going to showcase how does the whole emission controller work. So I'm going to venture prime again. Hang on a moment. Hey, what is this? Did I do something wrong? Oh, I think I know why. Sorry, give me a moment. Okay. So I'm going back to the chart. I'm going to redeploy WordPress again. Okay, install. Put into WordPress. Namespace. With a simple password and load balancing. So just now I think I have put in some unauthorized alphabet unmaking D. So I install now. I think everything should work. Okay, seems like everything is working fine now. So I'm going to showcase emission controller now. Sorry for the delay. I'm going to deployment, and then from here I'm going to create. Is this under user namespace? Okay, so there's this tab over here. So this is where you toggle between namespace. This is quite important because sometimes you might be in the wrong namespace, which is why you're not able to see the application that you think is supposed to be running. So it's user namespace. You're going to create a deployment. So I'm going to create just a simple deployment called hello world. Put it now from Docker, latest version of it. And then I'm going to create, and it's going to run within a couple of seconds. Okay, it's now running. So if I go back to new vector, remember I put emission controller into the monitor mode. So the deployment is going to succeed. But at the same time, if you go to the risk report, so think of the time, it should be 7 o'clock now. When I refresh it, it's further down. Yeah, you'll see that there's a warning that this is something that is not supposed to be happening, but since you put into monitor mode, it still happens. So next thing I want to do is I'm going to put into protect mode. So when I put into protect mode, right? So let me redeploy the hello web application. When I do a redeploy, okay, sorry, when I need to go to the pod, I need to delete the pod. And then when you delete the pod, you'll find that the new pod, normally when you delete the pod in Kubernetes, a new pod will be spin up. But in this case, the new pod won't be spin up because it is not allowed to be running in the cluster anymore because of the initial controller. You have set it to protect mode. So you go to deployment, you see that now it's a warning that you are not able to do that now. Okay, so the next thing I'm going to show you is some of the rules. So let me go to policy. This is the place where you are able to set all the rules. Go to groups. Every time when you deploy a new container, automatically there will be a group based on that. So I'm going to remember I just deployed the WordPress application. So you'll see that there's a group based on WordPress, based on the deployment. So there's 2 deployment that's being done on the WordPress application. So you click on this over here, you are able to see, what are the current members, what are the rules that is currently on this particular deployment. So you can see from here, after you deploy the deployment, the pod, right? New vector automatically already learn many things, including the process profile rules. You can see that there are many processes that new vector learn automatically. File access, like starting on this application. And then network rules. You'll see that there are network rules that has already been learned. So And there are some other things, right? Just now, someone asked about WAF. You are able to add your own WAF inside there. We have a couple of predefined WAF. If we have the time to, I will do a demo on that. But I don't think we have enough time for that. And DLP as well. So what I'm going to do right now is I'm going back to my Kubernetes cluster. Let me close off this. So I'm going to my WordPress pod, deployment, and then from here I'm going to execute the shell. So I'm able to see it's so easy for me to go into any containers and then from there run the shell from the Rancher Prime console. So what I'm going to do is I'm going to run the curl. Let me go back to new vector. So notice that at this point of time, when it comes to the process profile rule, there's no curl. Curl is not something that has been pre-learned. So now I want to include curl as one of the actions that can be taken within the cluster itself. So I'm going to switch mode over here, and then I'm going to switch to basic. So 0.3 doesn't allow things to change from the baseline. So I'm going to switch to basic, and then it is in discover mode. So I click on submit. So after that, if I run the curl command, the curl command is going to complete. And then if you go back to new vector, you will notice that do a refresh. You'll notice that curl will appear after I do a refresh. So curl appears now. So this is discover mode. Discover mode is where you are able to add some of the rules that you want onto the cluster. So once you are satisfied with whatever that you have set, you can set it into monitor mode. So I'm going to send to, before I send to monitor mode, I'm going to delete away the curl. So I switch into monitor mode. I submit. So now when I run the curl command, if you check out the notification, you'll see that it will be triggered as a warning in the security event logs. So when I run the curl command again, it completed successfully. You go back to this place over here, you refresh, the curl command will be added now. And if you go to the security events over here, you do a refresh, you'll find that there's a warning on the curl command. Do we need to do a hard stop or? Okay, just one last thing. Okay. So one last thing to show you is if we put into protect mode, what is going to happen, right? So now we put into protect mode, we submit. And then when we run the same curl command, you'll find that operation won't be permitted. And again, if you go to new vector, you're able to see that there's a security event. Okay, so unfortunately, time has run out. We are not able to finish the whole demo. But luckily, in 2 weeks' time, we have something called new vector review. So during new vector review itself, you are able to go through all the things that I've shown you with so much more other things that I think is going to be very interesting to you. So please feel free to sign up with our new vector review. It's going to happen in 2 weeks' time. And you are able to do hands-on together with with our trainer. So it's definitely going to be better than just looking at what I'm doing now from the demo perspective. Thank you everybody for your time. Thanks.
All right, thank you very much. So we have our next speaker, Chammpika, and he's from Rakuten Wiki, who would be talking about Kubernetes cost optimization, Rightsizing. Hi, Chammpika, you can take it. Sure.
Thank you, Ritesh. How are you all doing so far? Pretty much good, interested session. Yeah. So my name is Chammpika. So I am the SRE manager for Rakuten Wiki. So today I'll be talking about our journey which we went through on achieving the cost efficiency through the right sizing. So just to share a little bit about Wiki, just to set the context about what sort of workload we are managing. Wiki is a media streaming company. We bring Asian entertainment content throughout the world. We have about 40 million fan base across the world throughout 190 countries, and we subtitles over 200 languages as well, all our shows. So majority of our workload is hosted in the GKE environment, and it is provisioned with over 150 nodes. All these clusters are geographically distributed in order to make the redundancy and achieve the low latency and the low response time as well. And all of them are managed through the ISE. However, we have not set the HPA at scale as of now. The reason behind that was we wanted to set all the fundamentals right. So we wanted to make sure that we are using the right amount of resources and on the right places. So otherwise we could have just enabled HPA and let the magic happens. We didn't want to do that. So that is all about today's session and what are the lessons we learned while doing this right sizing exercise. So when we look at our infrastructure, the cost, we just understood that we are just spending over $100,000 a month just for the Kubernetes infrastructure. And the practices we were using for the resource allocation were very minimum. Excuse me. The efficiency of the cost is very low. Since we have enabled our development teams to manage their own applications, we understood that a lot of resources were generously allocated. So with all of that, we thought like we need to do the right sizing exercise in order to make sure our infrastructure is using the right amount and there is no resource being wasted. So what is the approach we were taking on that exercise? So the very first thing we did was to understand what are the industry best practices for setting the CPUs and memory limits. We were following our own things, but we wanted to understand what other people do. The next thing was we wanted to know like what is the current cost efficiency and the utilization patterns of our applications. Once we had all this information, we did the organization-wide engineering session to make the awareness to our engineering teams on what is the importance of maintaining the cost efficiency and how we could utilize our resources in the right manner. Then the rollout of the changes done in the paced approach. Of course, we started with the less critical applications and compared the matrices before and after we did the right sizing, because we wanted to make sure that after right sizing there wasn't any performance degradation or there wasn't any latency related issues of any of these applications. So what are the tools we use for this? We are mainly on GKE. So we, of course, use the native tools came up with the GKE to understand what are the cluster utilization and how we are doing with our underlying infrastructure. And for the applications, we are utilizing the Datadog, which is our APM. This gives very insightful information about how our applications are being performed. And of course, it helps with the alerting and anomaly detections as well. This is one of the important tools which we have deployed in our clusters. That is the KubeCost. KubeCost is capable of to provide more insightful information about how much cost is allocated for each application and each pod. So this will help us to monitor our cost efficiency. Otherwise, if you just barely use the GKE or the Datadog related metrics or the billing information, it is not very straightforward for you to understand how much cost efficient you are as an individual product or an application. So this help a lot of with those, especially with the cost aspects, and it would also suggest the performance, the optimization insights as well. So I was keep talking about the cost efficiency. So what is this cost efficiency is actually about? The cost efficiency is the ratio of how much cost for the requested resources versus actual utilization in a given time period. So let's take a look at of this example. A container requested 2 CPU and 1 GB of memory, but it actually utilizes 500 millicores of CPU and 500 MB of memory. The actual cost for the CPU on the node is $10 per CPU, and RAM is cost $1 per GB. So these particular applications, the cost efficiency is based on this calculation is 26%. So in our exercise, what we targeted to achieve the 50% of the cost efficiency. The reason behind this, we wanted to have enough headroom to grow the application, and we don't want to compromise our application performance as well. So that was the target we were following during this exercise. I know all of you are familiar with setting the limits and the requests, so I just wanted to go through it a little bit. It will help to me to set the context for the next few slides. The request is amount which is the guaranteed by the Kubernetes scheduler, and the limit is what is the maximum amount of resources your containers could consume. Memory, when it comes to the memory, it is non-compressible resource. So when you allocate, unless and otherwise you kill the process, you can't take it back. So if you look at this example, so this is a node with 6 GB RAM, and it already had 3 containers scheduled, and the remaining memory is about 1.5 GB, and there are 2 containers waiting for getting it scheduled there. One is request 2 GB, and the second one is requesting, the container 4 is requesting 1 GB. So only the container 4 get the priority because there is no enough headroom in that particular node to cater the container 5. What happens if the existing containers in that node start consuming the maximum amount of allocated resources? So in the Linux subsystem, they have the OOM subsystem, which looks after how much memory is consumed by each process. So when it hits the allocated limit, it will execute that process and do the OOM kill. If the PID is set to 1 of that process, then it will restart it. Otherwise, it will just dies away. Next thing is about the CPU. CPU is all about computational processing time, and actually it measures in cores. Let's see how the time and the cores are related, right? So if you know the Linux use the CFS as the scheduler, the complete fair scheduling in this algorithm it's utilized. So each core is 1 CPS period long, which is 100 milliseconds. So in this example, there are 10 cores. So altogether, there are 1000 milliseconds you could have, right? So if a container requested 0.5 core, the scheduler will allocate 50 milliseconds for that process. So how it allocates the 50 milliseconds, it could be decided by the scheduler, and it could be either in one core or it could be in multiple cores as well. So what happens if you set a limit here? Let's assume there is only one container runs in this 10 core node, and you set the request to 0.5 cores and the limits to 2 core. And even though you have enough headroom to grow, when you hit the limit of 2 core, the rest of the resources will be wasted. So this is one of the key consideration we took when we are designing the limits, especially. So this is an illustration which explains you about what would be the sweet spot about allocating CPU and the memory. limits and the request actually. So if you set the limits, basically it explains as you can't use the excess resources in the core node. And the most practice way in the industry is set the CPU without limits. So that is the one of the practices we also adopted. So what is the strategy we followed to for this cost optimization exercise? The very first thing we did, as I explained before, we analyzed and gathered all the cost metrics. And the next thing we did, we labeled all our workloads. We used labeling in Kubernetes, and which help us to uniquely identify all our applications deployed in these clusters. And once it is done, then we moved into the setting the limits of the request limits of the CPU and the memory. And especially in the CPU, we did not set any limits, but request only the request parameters. But when it comes to memory, we set request and the limits are into the same value. So that the main reason for that, we wanted to make sure there aren't any other containers running in that node will not get killed with the OM. So that is the main reason behind that. In our exercise, we identified multiple patterns of our applications. These are some of the patterns we identified how our applications are behave. So one is the constant utilization CPU. So that is throughout the time period, it's mostly consistent. For those kind of application, what we followed is in the 100 percentile, we looked at what is the maximum CPU and added 20% buffer on top of that, and did not set any CPU limits. And this is another one we follow. We call it wave pattern. In this wave pattern, what we had done in the 100th percentile, what is the maximum CPU it hits, and we did not add a buffer as a buffer in this case. The reason behind this, it has enough headroom to fluctuate for this application. This is another example, so I will not go through in detail. So what I wanted to emphasize was we had done a thorough analysis on each of our applications behavior, and based on that, we had to customize some of these requests and the limits. For the memory, we followed the same approach based on the data we gathered. We looked at what is the highest utilization in the 100 percentile and added some 20% buffer on top of that. The specific thing to highlight here is the request and limits are set to the same value in both the scenarios. Mostly the APIs. There are some scheduled jobs as well. We have similar data analytics, but in a different cloud platforms. Yes. Not massively, but just little bit. Yes, but not in GKE. Yes, please.
I mean, when you actually estimating or calculating the cost, you're targeting only the Kubernetes or overall the infrastructure?
It's a two-based approach what we had taken. So one is specifically targeting the Kubernetes workload, and then the external resources. So which comes under like PubSub, Cloud SQL, all those other resources which are external to the cluster.
Yeah. So I mean, just trying to understand, when you say example Google Functions, you're using Google Functions, or maybe the virtual machines. So if we take another approach, having the, like, say example, a reserved instance in the Azure, similar case, which will again contribute to the lowering the cost. So I mean, is this something that we have considered here also, or?
Yes. So those were done initially.
I see. Okay.
So once it is done, we wanted to do what more else we could do. So that is the part of the exercise.
Okay, sure.
Yeah.
Thank you. Thank you.
So this exercise, I would like to see it as a five-based approach. So the very first step start with the analysis part. Then you need to identify your threshold, which will be, of course, depend on the behavior of your application, and then define the best practice which will applicable for your organization. There are enough things you could find out there what others had followed. They are useful, but don't directly try to use it. But after your analysis, try to define those. Once this is done, then you can proceed with the right sizing exercise. And once it is completed, you must set the budget list as well. Otherwise, you may not know this will grow again with if the HP and everything is enabled, and it will go haywire again. So you need to make sure the budget alerts are properly set. And as a practice, in our organization we at least monthly look at it, how our cost looks like with the tools we have, and of course we use the alerts as well. I would suggest at least quarterly you need to revisit this and do another round of optimization in order to make sure you are more cost efficient. Okay, this is very interesting graph. I wanted all of your attention. So this scatter plot chart represent two aspects. One is the cost efficiency of the applications, and other one is the total cost of the application. So these are real data. So I just masked the name of the application. If you look at this is a month of period. If you go further right, at 10 to 14, the cost efficiency is quite around 25%, right? And the cost is about $100 per month. But if you come way left, the cost is around like 25,000, but the efficiency is around 5%. So when you are doing the right sizing exercise, first you can get this information graph and understand where you need to put your effort. If you spend too much time here on your effort on right sizing, the gain you can could get is very less. So what is the gain you can get by saving $50 per month, right? But if you can bring down the efficiency into 50%, probably you can bring down this cost from 25,000, 15,000. So that is where you need to put all your attention rather focusing here. This is some of the cost efficiencies we were able to get. These having the data of 7 applications. So you could see the blue color column represent the efficiency we had before, and the green one represent the efficiency we had after the optimization. There's a one application. It's sort of already in a good situation, but rest of the application we were able to achieve considerable amount of efficiency. That comes to an end of my session today. If you have anything, please feel free. Any questions?
What was the limiting factor using that one? That one is the highest cost.
The main reason is it's quite old as well. It requires a lot of refactoring also, so which required engineering bandwidth allocated. So which we are planning on the phase 2.
So even with CPU requests and memory limits, you are not able to improve it by much.
Much, yeah. There are other factors as well we need to consider.
That's your most expensive application.
True.
How the response from the F1
It's actually collaborative effort. So how we operate is our development teams build the products and they are responsible to operate it in production as well. So we as the SRE team, we make sure we enable them with the enough resources they want and the enough automation in place. So they are quite taking the ownership of what they build. So the initial response was, I would say there wasn't any hesitant, but the challenge was to allocate in the time because it's quite hectic exercise for them. Initially, it took 2 weeks, one sprint worth of effort we had to put to gather the initial metrics and the data. Then the next approach is to set the limits and redeploy, which didn't actually take much time. We knew our baseline because of the Datadog we had. So what we wanted to make sure was our response times or the latency stays the same. So that is why we thought like the maximum we will target at this space to achieve the 50% of the cost efficiency. Yeah.
Cost calculation.
Yeah. Yeah, yes. The reason to use the tube cost is if you look at the GKE or any other clouds cost explorer, it doesn't give you the pod level of cost, what it costs to run a pod in the production. So it gives to your GKE or EKS cost. So we wanted to understand how much each application will cost to run in the production. Then only someone think, let's say I have an application. So I operate in production. I know the revenue which generates, but I don't know how much I will spend in the cloud, right? Because it's a shared environment. We host multiple application in the same cluster. So there could be other application who actually fund these resources to run that particular application. It might, let's assume, only earn $1,000, but the actual infrastructure could be $5,000. So we wanted to understand that what is the cost benefit of operating an application. Yeah.
What was not there in Datadog or like GKE and what was this?
Yes. So in Datadog, we have all the performance metrics and the utilization and everything, right? GKE shares the similar thing with the cluster level, but it doesn't tell me what is my cost efficiency. It doesn't tell me where I could get more cost optimization. So that is where the cube cost come in handy. Yes, please.
For a project this size, I'm wondering how long was the project working before you implemented all the best practices, and if there was a threshold that you reached or a cost that made the decision being taken.
Yeah. So before coming to the GKE, we were in the, I would say, data center, but still with the containerization. So then we came to the GKE environment, and at that point, we had, we didn't know much about the cloud and how it should operate. So it was actually running very generously at that moment. Then the team started the optimization slowly, and it comes to a point that we realized that without further refactoring or doing anything in the code, there are certain other level of optimization we could achieve. So we wanted to make sure our operating budget is way under the target. So we took as a challenge the team, so with the help of developers as well. So that is where the turning point actually. I mean, it is not that we get some pressure from the top or anything. So it's come as engineering initiative. Yeah. Yes, please.
Is this the only cost optimization is applied on the resources, CPU or memory? Is it also the storage somewhere?
Yeah, those are external to the cluster. So that was handled in a different place. That was the initial place we actually did. So we looked at what are the stale volumes and how, are there any unused backups? Are there any unused clones? Are there any idle VMs, idle projects even in the GKE? So those things cleaned up first. So then we definitely know that cost is already eliminated and we saved that. Next step is about how we can further optimize our containers.
Did you?
Yes. We looked at the cross-regional cost as well. One is about GCR, Google Kubernetes, Google Container Registry. So in one of our scenarios, we were downloading images from North America region to the Singapore region. So in the staging environment, so one of the optimization we did, all the staging content images should be in the Asia region. So in that way, we were able to reduce the egress cost.
Did you pay to cube cost?
Yeah, we do. But they
So
have
that was also a big cost, or I mean, if we see.
So I would say in that way, if I am able to optimize my app one to 10,000 from 25,000 in a year, I will save that.
Okay.
Yeah, something like that.
I had a question regarding, let's say, during a spike scenario, you have one show getting released on Monday, and all of a sudden the load increases. How do you manage it?
Since we didn't set any CPU limits, there is enough headroom. It could grow.
So it will throttle.
It will not throttle if there's enough, because we always made sure there is enough headroom in the nodes as well. So it could grow as there is no limit set in the CPU.
So you're having a bulky node basically.
We having
Bulky node, heavy node.
bulky in the sense multi-node. Yes.
Not bulky,
yeah.
bulky as in having large core CPUs.
Not very large, but we make sure always there is some headroom available for these kind of scenarios to be handled.
Okay.
But we do not over provision as well.
Okay.
Are you not using autopilot for GKE?
We do not use autopilot.
Okay.
Generally has the lowest cost efficiency and which one is the higher ones? Oh, okay. Yeah, I want to ask which design pattern generally has like the worst cost efficiency and which one has the highest? Or is it like a per app basis?
This is actually per app basis. Yeah.
Thanks.
Okay. We'll take two more questions.
Not sure if I missed this, but did you monitor your node resource utilization before and after this exercise to see if it's improved or anything?
Yes, we did. So one thing we observed is after the right sizing in one of our clusters, we got 4 node reduction from 19 to 15.
Just a generic question.
Yeah.
Let's say if you're getting the bill from the cloud provider, right? Yet your cost and then their cost will get matched.
The cube cost is integrated with the cloud billing in the GKE side. So with, I would say, 99.95 level of accuracy, they are quite equal. But this doesn't contain the external cluster resource cost like Cloud SQL, PubSub, those things. It doesn't
Storage.
include.
Okay.
Yeah, true.
Okay.
Right. If there is no more questions, then we can wrap it up. Thank you very much for joining us today.
Just one question from online.
Okay.
Do you mind defining the cost efficiency again?
Yeah. So cost efficiency is actually the cost. Cost of efficiency is the actual ratio of how much cost we request and how much is actually being utilized. So this is the algorithm it used to calculate the cost efficiency.
So thank you very much, Chammpika. Thanks a lot for such a wonderful session. And so we still not done yet. So we have some swags and quizzes that we want to make it a bit fun of an activity. So my colleague Fazil will continue the presentation.
Yeah, thank you guys. Please like our LinkedIn page. So if you are not following, so and help us sharing among your network also. Right. So we plan two games. One is a quiz game. So we'll be giving away swags for the first top 5 winners. So I'll move to the next QR. Yeah, this is the quiz game QR. So you can scan it and you can enter the quiz game. So if you're ready, so I can launch the quiz game.